Good evening, ladies and gentlemen. We warmly welcome you all to the today's webinar conducted by the Green Building Council of Sri Lanka. Today, we are going to discuss about a special topic in our webinar. It's enhancing disaster resilience in green buildings, a path towards a sustainable, resilient built environment. In a world where the impacts of climate change and natural disasters are increasingly prevalent, it becomes imperative to think how we approach the creation of our built environment. Let's embark on this journey together towards a more resilient and sustainable built environment. Welcome and enjoy the insightful discussion. Today's webinar will be conducted by highly valuable expert possessing intensive industry knowledge. They are Professor Priyan Mendis, Professor Anjit Disanayake, and Dr. Chandana Siriwardana. To start the session, first of all, I would like to invite Professor Anjit Disanayake to share his valuable knowledge with this great audience. Professor Disanayake is a senior professor in civil engineering at the University of Peradeniya. He is the president of the Institution of Engineers Sri Lanka and the immediate past chairman of the Green Building Council of Sri Lanka and a vice president of the Chamber of Construction Industry. He is also the former secretary to the State Ministry of Rural Roads and the State Ministry of Urban Development. Professor Disanayake is a Fulbright scholar in the USA and Endeavour Fellow in Australia and JASO Research Fellow in Japan. Professor Disanayake received the Overseas Prize of the Institution of Civil Engineers in the UK in 2007 and the Australia Alumni Excellence Award in 2012. He has published over 300 papers and chaired more than 14 international conferences. Some of his research interests are stable built environment, green innovation, and entrepreneurship. He is the founder of GAP HQ Colombo 7, the base of operation of several companies, including Lego International Private Limited, ICB Private Limited, Lanka AAC Private Limited, GAP Private Limited, and Brangler Solution Private Limited. Professor Disanayake is co-chairing the 14th International Conference on Sustainable Built Environment at Kandy and the first International Conference on University Industry Collaboration for Sustainable Development at Colombo. Dear sir, over to you.
Thank you for the kind introduction. Let me share the screen, please.
Yes, sir, you can share the screen.
Right. Good evening, everybody. It is my great pleasure that I start this webinar with the topic of a path towards a sustainable, resilient, built environment. So let me give you the introduction from the beginning and let me briefly explain why we went on the disaster resilience combined with the sustainability. And of course, this is the research work done together. So therefore, I allow Dr. Chandana to explain in detail about our finding and the tool that we prepare, so that I'll give you the introduction where you will understand why we went for such a topic. So let's start from the beginning, the sustainability. Of course, there are, as we all know, there are three pillars of sustainability: environmental, social, and economical. Basically, you can't have the sustainability without having these three: environment, social, and economic. So what we have seen here, that not the fourth angle, but the another area of importance, disaster risk reduction. Because it should be the whatever the built environment that we create must withstand again the in case of disaster. As the climate change is happening, disasters are increasing. So how, that is what we decided, how we are going to incorporate the disaster risk reduction into our main program. So just to start from when you go to I'm just going to explain you the three pillars, because with the development of the built environment, we have created a built environment which now we cannot sustain, survive. There are so many issues. So what we do is we are trying to find out the solution where we bring the nature back to the built environment. Again, for how we get the solution, again from the nature. We were in the nature, we went to move on to the built environment. We understand the built environment, we have a lot of issues. Therefore, we build a sustainable cities. What we do is again, we are bringing because what your daylight, rainwater harvesting, cross ventilation, I mean, you name everything. Actually, what is that we had in the nature? So we are bringing back the thing. This is what we are basically trying to do in the Green Building Council of Sri Lanka. So, sustainable built environment. So we create the built environment. We understand that we can't survive in the built environment. We are trying to bring the sustainable built environment. Similarly, when you go to the economy, so we again understand we have a big pressure in the economy. This is another pillar, no? So therefore, without having the sustainable economy, you can't survive. That is also, we have the many things to get from the nature, like the renewable energy, clean water, clean air, and so forth. Again, don't say we can learn many things from the nature in order to have a sustainable economy. So now we have talked about the environment, economy. Next one is the society. People are not happy. They have a lot of issues. Right? You might see on the street, people are not happy because they have so many issues. Then we have to make sure that we bring the happiness to the society. Right? So if you make sure that the environment, economy, as well as the social, when you bring these three pillars, only you can get the total sustainability. But we, Green Building Council, is mainly targeting about the environment sustainability. How you do it? For example, when we are in the jungle, I mean, everything get controlled by the nature. If the tree is fallen down after several months, it becomes a part of the soil. So we had a sustain, but what we did was we create the built environment and we increase the population. We end up with somewhere like this one. This is a photograph of the Colombo city. But when we target when we zoom to the different location, we understand everywhere we have created the problem within the built environment. Right? When you target, see the water bodies, fully polluted. Exactly the same thing when you go to the soil, polluted. It is the same there. These are the three elements of the environment. No? When you focus on the road, you end up with traffic. So therefore, you can't practice the existing built environment unless otherwise you make it the sustainable development. For the sustainable development, you need the environment, social, and economic. So how do you bring the sustainability? There are basically two actions. Environment, sorry, three actions that we already discussed. Social and economic. Environment protection, social and economic growth. But in order to bring the sustainable cities, we need the green infrastructure. We are mainly targeting about Green Building Council, public transport, renewable energy sources, waste management, water conservation. So assume this is the sustainable city. What are the ingredients that you can, when you focus into the water, you will see the clean water. You can drink water in case of emergency. That is the ideal situation. When you target into the road, you will see the sustainable transport. Different mode of, these are, can assume the maybe biodiesel, buses, public transport. This could, people use the bicycle, of course, cars also there. They just come to the station and park the vehicle and get into the public transport. But you, rather than some people has the mobility from their home itself, those who cannot have it, they can travel by their cars and just park it and get into the public transport. And maybe next one will be the train station. So public transport, the minimum usage of the other power generation and the public transport, of course. Then when you focus on the, but we do the Green Building Council, building has become, because if you do not have the building, so again waste and the various things are coming that consume a lot of energy and so forth. So these are the greener buildings. So that is our focus. So when you can't just have the building itself with a tree and vertical gardening. So we have to have the better practices. And you focus in the, just one area, waste segregation, right? Other area, the cross ventilation, daylight, right? Sustainable material, and many things should be included in the greener building. But again, when you go to sustainable city and society, the city which has the environmentally sustainable, of course. We have seen what we are going to make during the green building concept. And they're very important, socially resilient. Right? Socially resilient means a lot. It is economy, it is social. And this is where the disaster risk reduction comes. Disaster risk reduction. You can have the best greener building. But in case of raining, if the building is flooded, there is no resilience. In the case of raining, if the landslide come into the building, there is no resilience. In the case of wind, the roof blow away, there is no resilience. In the case of earthquake, building collapse, there is no social resilience. That is why we thought it is very important when we go for the greener building, we have to make sure that building will not be subject to the flooding, building not be subject to the other disaster resilience, because otherwise you cannot have the social city and sustainable city and society. That means which is the environmentally sustainable and socially resilient. That is the main reason why we decided to research and convert in the existing green building tool, which will make sure that the we have the disaster risk reduction. I think now I have given I'm not going to describe about the strategy. I will hand over back to the control to the Ms. Dinushka, with the Green Building Council of Sri Lanka. Then she will introduce our next speaker and he will explain how it was incorporated. Over to Danushka.
Okay, sir. Thank you very much. Can I share my screen, sir?
Sure, sure. Right, I stopped sharing.
Okay, sir. Thank you very much. Okay. I would like to invite Dr. Chandana to share his valuable knowledge with this great audience. Dr. Chandana Sirivardhana, a senior lecturer at Massey University's School of Built Environment, is renowned for his numerous publications in esteemed international journals and presentations at peer-reviewed international conferences. His extensive involvement in global disaster and construction management research projects funded by prestigious entities like Erasmus, EPSRC, and GCRF has significantly enriched his expertise in this domain. Before assuming his current role at Massey University, Dr. Sirivardhana served as a senior lecturer in civil engineering at the University of Moratuwa, Sri Lanka. He is a green accredited professional with the Green Building Council of Sri Lanka and holds qualification as a Green Star practitioner and Home Star practitioner, V5 with the New Zealand Green Building Council. His research predominantly focuses on integrating disaster resilience into green building practices. In recognition of his significant contribution to the field, Dr. Sirivardhana was recently honored with the prestigious Outstanding Green Professional of the Year Award 2023 by the Green Building Council of Sri Lanka. Dear sir, over to you.
Thank you, Dinishika. Let me share the screen. I hope you all can see the screen.
Yes, sir, we can see the screen.
Right. Hey, thank you for giving me this very valuable opportunity. I'm truly honored to be part of this webinar along with these two distinguished professors. Therefore, my sincere gratitude goes to the Green Building Council of Sri Lanka. So today's our topic is enhancing disaster resilience in green buildings. So I will be explaining uh, the uh, the disaster resilience and how we integrated that to green building rating tools. And then Professor Ranjit has given a very nice introduction about this topic, and Professor Priyan Mendis will be giving some strategies as he's the expert in this area. So moving on to the presentation, let me share a couple of pictures of a field visit, which I had the opportunity to participate very recently. This is one of the private houses built by an architect in Auckland. Yeah, he used rammed earth as the main walling material, and all the building materials are recycled timber or recycled rock or everything is recycled. So this is the perfect example of a green building where he tried to minimize the environmental impact, and this is a living project in fact it is, because he has been adding many features to this house while living. That is his hobby, and that is his living environment as well. Now, while moving across this building, while getting amazed by this architectural masterpiece, I came across couple of issues where I see that this building is these walls are not being plastered, and in outside and inside both. So then it's exposed to the extreme weather conditions. And also, if you, I don't know whether you can see it or not, there is a crack. There are a couple of cracks. Probably you know that in New Zealand there are earthquakes are uh, very common, and tremors are also. Therefore, I thought these cracks might be a reason because of these tremors or movements in the ground. And also, today in one of the websites shared this uh, news item where it said Auckland Council warns a possible intense rainfall, risk of flooding this summer uh, due to El Nino. And if you read here, it said even if they haven't seen flood waters near their properties before. So even though these countries are highly developed, uh, they can't escape the climate change and the changes happening in the environment. Therefore, they are going to do many proactive measures, and going to develop interactive maps showing in flood risk data for the whole region. So they are taking action, but the point is the weather is predominantly changing, and that going to affect this very nice architectural and environmental friendly sustainable building. So which makes me uh, worried about that gentleman who is spending a lot of time on developing this building. And another thing is that you all probably know that last year was the recorded the highest ever temperature recorded, like during the summer in Europe. And also these days you probably have seen in Canada, if you have friends over in there, lot of cold weathers and colder periods, and that is also extreme. So we see the two extremes, right? So back in the days when we were worried about COVID, we thought, okay, COVID is the main issue we are having. And then we thought when we can overcome this, because we lived happily before COVID. I mean relatively. And then we never thought there going to be a recession soon after COVID. Not only in Sri Lanka, like people in Sri Lanka might be thinking, okay, recession is only is happening in Sri Lanka. Not it is not. It around the world there are economic downturns happening, and it is real. Back in the days, we thought it is not going to happen, but now we are not giving much attention to climate change, but it is going to be very real very soon. So we in one hand, the climate is changing, and this is the global risk report produced by the Economic Forum. Please have a look if you have not read it. You can Google it and you can find it. You can see that all top four risks are related to environmental. extreme weather events, critical change to Earth systems, biodiversity loss, and ecosystem collapse, natural resource shortages. And in the right-hand side of my slide, you can see that how global risk landscape and it interact with each other, how it is connected to each other. So this is environmental, and how the environmental leads to economic, and the economic leads to environmental, and so on. So here you can see that collapse of systematically important supply chains. We all know that how dependent we are to supply chains, not only in Sri Lanka. Sri Lanka, we have all gone through these fuel issues and all that, not only in Sri Lanka, but in other countries as well. Due to these supply chain issues, housing market and construction industry has faced a lot of issues. So everything is interconnected. And at the same time, disaster impacts also increase. And if you focus on this figure here, you can see that so compared to previous decades, the disaster events are uh, frequent, and the intensities are frequent. The economic losses are also very high, and that is also indicated here. And moving on, so as a precaution, as a proactive measure, the global community, the United Nations, and so on, they have taken proactive actions. In 2015, they came across and set together and developed different frameworks to fight against these climate change and economic situations and disasters and so on. So two main or three main focus areas would be sustainable development goals, Paris Climate Agreement, and Sendai Framework signed in Sendai, Japan, where it's about all about disasters and disaster risk reduction. And their target was from 2015, they all agreed to set of common frameworks as countries. And then by 2030, we're going to achieve them. But 2030 is like only 6 years away, and most of these targets were still not being achieved. And you can see that how these are not isolate framework. These are all interconnected, and then benefiting each other. And then in order to achieve, let's say, sustainable development goal, you need to fulfill the targets of Sendai frameworks and Paris Agreement. So you can't take one and isolately try to achieve them. So we need to look holistically. So again, if you like now, in order to meet the climate change, global warming targets, in order to stop that, this is the path that we need to go in order to maintain at least livable, climate resilient world. That we need a full societal transformation, and then we need net zero, lower emissions, and that will limit global warming. But we are nowhere near that. We are still going through business as usual. Countries are fighting with each other, bombing in everywhere. So no one is giving attention to the future. But we are again going to face the consequences like we are facing, and we are going to face them. Now, as you can understand, we have one hand sustainable development as a target, and another hand that we need to we need to achieve the disaster resilience. So resilience to the disaster, as well as we need to achieve the sustainable development. So sustainable development was uh, this triple bottom line has been introduced by Professor Ranjit, and then I'm not going to explain it further because he has explained it very well. And disaster resilience, we'll look into it more deeper down the presentation. So mainly the three things that we want to focus in developing a disaster resilience is that we want to reduce the chances of shocks. Shocks are sudden impacts which can happen naturally or man-made, or and then absorb the shocks if it occurs, and then recover quickly after a shock. So in fact, some people getting confused with the relationship between sustainable development and disaster resilience. In literature, if someone is moving the cursor, could you please stop that? So the relationship between sustainable development and development and disaster resilience. So in literature, it's kind of confusing because
Even no, Mahendra is
okay. So please don't move the slides if someone is doing that. So relationship between sustainable development and disaster resilience. So then the this resilience term, disaster resilience term, and the sustainability, it's in literature, it's people take it, researchers take it in a different based on different definitions. Some say sustainability equals resilience if a society or a city or a building is resilient, then it is sustainable. Some say resilience is a subset of resilience, sustainability. Some say resilience, sustainability is a subset of resilience, or they are two different uh, entities. But in a very simplest form, we can take them as two different aspects, two different entities, but they will, if you achieve resilience, it will benefit to the sustainable development, and then sustainable development will make a city or country or region or community resilient. So they work hand in hand. So the best way to explain the resilience is to take it as an example of a spring. So the spring is able to take any shock, and then it will go down, absorb the shock, and then come back to the original level without having any impact. But if you do it in a intense way or more than the spring can hold, so then it will go beyond the resilience capacity level. So we will focus on to or discuss that in a later slide. So what we need to understand here is the exposure to the hazard, the vulnerability to the hazard, and also the level of preparedness of the community or the city or the region or a building. So the resilience ensures that shocks and stresses do not roll back development goals. So if a community is resilient, they are in a path towards a sustainable development. So then if you look at in a more general format, in a mathematical form, we can put it into a diagram like this. So if a system performance usually with time, technically, theoretically, it should go up. But there are I am not a fan of using this natural disaster term. We can call it natural event or natural hazardous event. And then because of that event or man-made event, so the performance of this system will go down, and there could be a very sudden drop, and it will eventually come back to natural, normal, original level. Or if the society is not resilient, it will go down, and then the system performance will not come back to the original level. Or if the community, if the policymakers or the regulatory bodies or the governments take in actions to fill the gaps enhance the capacities, make the society prepared, and take proactive measures, they can come to a higher level than the original system performance level. So whenever there is any other natural event, undesirable natural event, which make the performance drop, it will again come back, or it will not make the same amount of drop in the next time. So to explain it further, I want to highlight this quote by Mami Mitsuri. She's the head of UNDRR, United Nations Disaster Risk Reduction. And according to her, for every US $100 spent on development aid, only 50 cents are invested in protecting development from the impact of disasters. So I have highlighted why it is important to focus on disasters. The climate is changing, climate change again contributing to disasters, making the disaster impacts higher. And uh, according to her, this is equivalent of building a car and deciding not to install brakes. So we build a car, and then the most important component is missing. It is the brakes. So let me explain why she's saying like that. So if you look at any country, theoretically, the GDP should grow, but there could be undesirable events. So this undesirable events could be to the physical environment. So we'll look into this the definitions of this built environment in a next couple of slides. But whatever the event, so this event, if you don't have any investment on resilience initiatives, resilience initiatives, right? So then resilience initiatives are the measures that we take to push this undesirable event back to back to where it's supposed to be. But if we don't have any investment on that, so we will go down to a undesirable end. Like if you look at like after tsunami, uh, like how many years it took us to it took to come certain communities who got impact from this very tragic event of tsunami, come back to their normal lives. Probably still some of their lives are not came back to the original level, right? So then that is because not taking proper investments in resilience initiatives. So these resilient initiatives are not only taking to the physical environment, but to the everything. I will come back to that later. Now, if you invest on this disaster risk reduction measures, it will push uh, the development again back to some desirable level. But again, they are going to be undesirable events, natural or man-made. So then that will again reduce the system performance. But we need to take again these investments. So it is where we are highlighting that. And then so thanks to that this DRR investment, so the society will go up than the unexpected level. So now we need to be prepared than before. If a business, let's say our business is solely focusing on local customers, local suppliers, and everything depend on local. But then local in let's say for an example Sri Lanka, right? Our business is solely focused on Sri Lanka, and then if that due to financial crisis, which is an undesirable event, happen, and then if we are not taking any actions to think innovatively, make investments to move out from that event, like for example, focusing on other markets available outside Sri Lanka, right? So then sometimes we might be able to overcome that issue, or else like if the our resources being impacted. So then if we can't go into the conventional construction practices, what are the alternatives that we can go for an example, right? So then these investments are very critical. Otherwise, we'll not go in the correct development path. Right. So then this development, like the difference between a resilient community versus vulnerable community is that when there is a shock, the resilient community, if the community is resilient, like easiest way to explain the resilience is through easiest way to explain the resilience is through by taking an spring. So if the community is resilient, they can take the shock. This is the shock, and they can bounce back. They can take the shock and they can bounce back. So then their level, system performance level is more than it's supposed to be. But for vulnerable community, they are not ready. They don't understand the situation, what is going on. They have no capacity to no capacity to take decisions. There is no information available. So then they will go down. Now that's the example which I have shown at my very first slide about Auckland Council providing this information. Look, this is going to happen. They are going to be they are going to be heavy rainfalls going to happen during this summer, and you have to be prepared. And this data will be available, and interactive flood maps will be available for you to check whether your land or your building is at flood risk or not. Right. So that is what a resilient community or building, that is the path of building a resilient community. So you have well-informed, prepared, and you can take proactive measures. Now the term is not only sustainable, but also resilient. So the resilient sustainable development is the term that we can use. This is also, I got it from UNDRR report, very recently published, came last week, if I'm not mistaken. So then the importance is we need to generate the knowledge. If you have the disaster risk reduction knowledge and any other knowledge on what is going to happen in the global level, local level, regional level, we can take actions to avoid creating complex risks through poor development choices. Sometimes we take very poor development choices, and these poor development choices make us more and more into traps. It can be debt traps, it can be environmental, it can create environmental issues, or it can create disaster issues, right? So we have to be very careful on taking poor development issues. And reduce complex risks by using development to reduce vulnerability, exposure, and increase resilience, and promote iterative and constant learning to improve capacities for sustainable development, right? So we need to reduce the risk by using development, reduce vulnerability, and we need to promote interactive learning and building knowledge. Now, coming to the with all that in background knowledge, I want to come back uh, uh, to the context of built environment. Now, built environment is not only physical, as we all know, it's non-physical as well. So the like even though you build buildings, that doesn't mean it is going to be a built environment. It's going to, you need social economic activities happen. Social activities should be happen, and there should be governance of these infrastructures and governance of these infrastructures, as well as uh, regulate regulation of these infrastructures. Now, if you look at the physical uh, built environment, it's mainly consists of buildings and infrastructures, and the interaction between the natural ecosystem, and uh, interaction between all of these dimensions. Now here in this webinar, like we can we'll be focusing only on the buildings, and so that is why the where the green building is coming. The importance of the green building movement as well as the intervention of green buildings is very important. Why? It is because within the built environment, buildings are the leading consumers. Why? Buildings consumes 40 to 50, 45 to 50% of the energy. These numbers can vary, depends on the country context, but this is in general. Like for example, in USA, it can be 65% because these countries are heavily dependent on the uh, energy provided to the buildings to create a livable space, because sometimes it can be outside, can be very, very cold or very, very hot, right? So then the energy is very important in this inside these buildings, and 42% in European Union, uh, and buildings contribute 40% of the climate change gases, 50% of landfill waste, and 40% of drinking water pollution. Now, so then connecting that to sustainable development goals, we all know that sustainable means that meeting our needs without compromising the ability of future generations to meeting their own needs. Now, if we build a building today, we make decisions mostly to today's context, right? But the consequences of that building will has to pay faced by the future generations. So the building is going to last for around 50, 70 years, right? So this building is a livable addition to the built environment. So then we have to be very careful about the decisions that we are making, as mentioned in the resilient sustainable development, if you want to achieve that. So then in the sustainable development goal, in the built environment context, the 9 and 11 are mostly important. So the 9 is about industry, innovation, and infrastructure. 11 is the sustainable cities and communities. Now, as I mentioned previously, so then green buildings is a very very important concept and movement where the green buildings trying to overcome these adverse issues. Communities have fundamentally changed their environment and adapted towards sustainability by creating healthy, most importantly, healthy, productive. So the people who are living inside the has to be productive and energy conscious. This building has to be energy conscious and capable of reducing significant adverse impacts to the global environmental human lives. Now, that is where the green buildings is going to be very great solution, and definitely it is not only in Sri Lanka, throughout the world. Green buildings is a now is a buzzing word as well as a trending topic. So then green building through its design, construction and operation reduces or eliminates adverse effects on our climate and natural surroundings while also having the potential to create positive outcomes. So then while making a building a green building, we are expecting the carbon emission to be reduced by 35%, solid waste generation by 70%, water usage. So like this is I'm not going into the every details of, because of the time limitation of this, how we can make a building a green building. So that is the purpose of the green building councils, uh, uh, like originated from Green Building Council, and then moving into the other green buildings councils around the world, and then they are targeting to achieve different sustainable development goals by taking different measures. Now, how to differentiate a normal building or a building from a green building? So that is for that purpose there are rating tools available. So we call them green building rating tools. In Sri Lanka, we have green SL rating system, and there are set of categories. Inside those categories there are subcategories where you can earn marks, and there are prerequisites, and if you follow that, there are a set of score ranges, and then based on that you can get the that is the basic concept. Some of you are experts in that area, some of you might not have any idea, so that's why I gave a basic idea of it. So then LEED is one of the most popular, and BRIM is the UK base, and then Green Star rating systems is available in Australia and New Zealand. Australian one has been modified and using in New Zealand, and mostly same concept, same way of categorizing them, but sometimes based on the cultural country context, they are changing the way they measure and threshold levels of these different categories. Now, as I mentioned previously, these green buildings and then the getting certifications are becoming more popular because now because of this climate change issues, now there are net zero targets, and most common or popular way to get achieve the net zero targets probably through green buildings. So then and also if you do it properly, it can be economical, and then in the long run you can make your expenses to a very low level as well. Now the question is it enough to be green? If you make building a green, is that enough? That's the question. So then like if you look at this different researchers' arguments, the dramatic increased trend of disasters due to natural shocks and climate stressors has threatened the sustainable development of the world. One cannot speak about sustainability for a structure in a hazard-prone zone if it lacks sufficient resilience against natural hazards. And again, it says through green buildings are capable of reducing environmental footprint, are designed to respond to adverse natural shocks and climate stresses. Now, all these researchers are highlighting the missing link, where the importance of linking disaster resilience to the green buildings, because in the green buildings the focus mainly on sustainable aspects. Of course, there are some resilient measures, but I will come to that later. So in green building rating tools, to ensure minimum construction standards and practices in sustainable development, green building rating tools provide major guidelines and specifications. GBRTs are instrumental in educating users, incorporating sustainable strategies into planning, design, and construction. However, now considerable gap in the potential and existing green building rating tools to incorporate hazard resistance and mitigation into broader context of sustainable development. Now, for example, even even frameworks like LEED or BRIM, like LEED is a US and BRIM is a UK based creating tool, and not including hazard resilience indicators that some researchers has highlighted that. And therefore, it is essential to integrate certain resilient indicators to a certain level to green building rating tools. Now there is a problem when you try to integrate these two, because when you try to make a structure, I think Professor Priyan and Professor Ranjit are experts in these areas, so I will let them talk about this in detail, but I will go into I will touch on the surface on this. Now, when we are trying to make a structure sustainable, what we try to do is in general practice, what we do is we are going to strengthen the structure. And then in order to strengthen the structure, we put more concrete, more steel, and then what will happen is we increase the embodied energy, and then eventually it is not going to be a sustainable or green building. it is going to be a disaster resilient building because it is more robust, but it's not going to be sustainable. But again, if you look at the green movement, for example, having a green rooftop is will give you more marks in green rating systems. But having a high mass concentration in a top of the building might not be desirable for high seismic, like for the earthquake resilient structure, right? So then there are contradictions when we try to merge these two concepts. Now, for example, if I take some examples from the literature, like for example, so then the importance for sustainability and then hazard resistance. Now, the uh, other complexity of this issue is now we have many hazards, not only one: fire, earthquake, wind, flood, landslide, right? So depends on the context, depends on the local hazard landscape. With the measures that we have to take is different. So then the designs that we do to the buildings, and then we want to make them sustainable, and then if we are trying to make them disaster resilient as well, sometimes they might not uh, uh, supporting each other. Now, for example, let's take uh, uh, now, for example, lighting system, site. For example, structural durability. It can be good for sustainability, but it might not be desirable for fire. And then uh, right. So then, so the HVAC systems, sometimes it is it can be desirable for sustainability, but it might not be desirable for seismic or wind or floods, right? So then different design considerations are good for sustainability, or sometimes it might not be good for fire or seismic or other hazard resistance. Now, here, what we need to look at is the overall construction life cycle. So then, like starting from the initiation, planning, implementation and execution, performance and monitoring, and until the closing. So then we need to understand the life cycle of this. So then again, I'm not going into details of it, but if you look at where the green building ratings are at, it is at the planning stage or the initiation stage. So then what kind of rating tool that we are rating range that we are targeting, and then what are the building codes, regulations, and then when you are doing the site selection, again, that is part of the, it will be assessed from the rating tools. So we need to think holistically rather than just go for conventional design practices. Again, I am giving some examples. So then not only, so building, as I said, it is going to last for at least 2, 3, 4 decades. So then not only at the initial stages, but at the operational stages, what will happen to this building? What kind of hazards going to be predominant in this area in the future? What kind of risk this area is going to face? Likewise, so then what kind of repairs that we can do? So it's always the most sustainable building is the existing building rather than the new building, right? So if you are going to demolish one building and develop another, that is not sustainable. Okay, so then if you're going for understand core elements of disaster resilience, we need to understand the context, whose resilience is being built, and then what kind of shocks and stresses which we are aiming up to, and then what kind of capacity that we want to improve, and then what kind of range of responses. So then, so some resilient indicators that we want to focus. Sometimes these resilience indicators which we want to integrate to our green rating tools or sustainable sustainable assessment frameworks might be enhancing the sustainability. For example, check and increase the resilience of brownfield area. It is increasing the sustainability. But for example, installation of lighting protections can be decreasing the sustainability because you are adding more materials to that. So likewise, we have to be very careful on integrating resilience indicators to rating tools. Now, let me show you quickly some study which we done together with Professor Ranjit Disanayake and some other researchers, which is already been published. So, importance of integrating disaster risk reduction to existing rating tools. Now, this is the same green rating tool developed by the Green Building Council. So we wanted to test if we integrate disaster resilience into this green rating tool, and then if we add more several indicators to that resilience indicators to that rating tool, we call it new DRR incorporated tool. I don't think still it is not, it is being published and practiced, but it is the great good thing about this is they tried it. So then it's there. So then it will be published down the road. So then you can see that projects A, B, C, D up to L, some were gold, platinum, and all that. It reduced to, for example, gold reduced to silver, platinum reduced to gold. Likewise. So then existing like the buildings which were rated as platinum, because of the absence of the disaster resilience or the resilience indicators, it became got a reduced points, right? So that is the importance of. So then we can't. Then if you are using, then my argument is, or my suggestion is, if you are going for a newly developed rating tool, so it is same range of set of marks or the certification might not be applicable to them because you are using a different set of indicators. So then you maybe it might needed to modify the certification as well. So quickly going through the last couple of slides. Now here, what we have done is we try to compare different rating systems like Green SL current tool and incorporated, we call it DRR incorporated tool, and then the lead UK and the US and the BRIM, and then sustainable indicators. How many sustainable indicators are there? How many resilience indicators are there in comparison? So you can see that then in the green version 2 or the with the integration of disaster risk reduction, there are many indicators have been introduced. So then even in the other green building rating tools, the resilience indicators also more in resilience indicators being introduced in the latest versions of the LEED and also BRIM compared to the previous versions. So in concluding my talk, I would like to highlight that. So it is very important to integrate disaster resilience to green building assessing frameworks, and it can be done, but it has to be holistically. We need to look at it, not isolatedly, but it can be done with the proper with this proper support from all the stakeholders, and there are other tools. So if we are not, if we can either keep the green rating tools as it is, and we can develop a separate set of tools for disaster assessment. For example, relief framework. It is US based framework purely to assess the disaster resilience, or FEMA, again US, to assess the resilience of the buildings. And so finally, I want to highlight that it is very important to systematically approach this issues, but looking at the life cycle of the entire life cycle of the building rather than looking at one aspect isolately. Right. Thank you very much.
Okay, sir. Thank you very much. Our next speaker is Professor Priyan Mendis.
Just give me 1 second. I will.
Professor Priyan Mendis is a professor in the Department of Infrastructure Engineering, University of Melbourne, and the director of the ARC Centre for Advanced Manufacturing of Prefabricated Modular Housing and the leader of the Advanced Protective Technology of Engineering Structures Group. He is the deputy director of the ARC Industry Transformation Research Hub, transformation of reclaimed waste resources to engineered materials and solutions for a circular economy. Professor Priyan is a world leader in innovative construction methods such as prefabricated structures, tall buildings, durability of concrete structures, technology of structures, wind, earthquakes, fire, and blast. He worked as a consulting engineer before joining the University of early 1990s. Professor Priyan is a member of the Australian Standard Committees, BD2 and the BD6. And he was a member of the ARC College of Experts 2005 to 2017. Professor Mendis obtained his PhD from Monash University, Australia, and he is the founder chairman of the GBCSL and is also a member of several institutions, including Institution of Engineering, Concrete Institute of Australia, and the American Concrete Institute. Dear sir, over to you.
Thank you very much, Shika. I want to just also thank the Green Building Council, and also I just share the screen. It's easier to go to that. Can you see the screen?
Yes, sir.
Yes, thank you very much. And thank you, Dinushika, and congratulations. I think I'm seeing a number of 400, close to 450 actually. People joining. It's really it's very good achievement, and to organize this. And I know thank you to Dr. Chandan as well, and also Professor Ranjit here, who is in Australia. I think the Auckland time is probably close to 4 a.m. and our Australian time is now getting to 2 a.m. So I had to also thank a couple of people from Australia. I see some names here, Daisy is here, and Danula, and I think Kavita. That number of people joining from Australia as well this early morning. So to really thank you for everyone also joining from different parts of the world, and of course organized by the Sri Lanka Council. So first of all, I want to also mention Sri Lanka Council is one of the first councils to introduce the social aspects to the rating system, and now that with this pioneering effort of disasters being included, I had to congratulate in this case Dr. Chandan and Professor Ranjit, like effort there, trying to incorporate that. So it'll go a long way in the World Green Building Council ratings. So to start from Sri Lanka. So thank you very much. Actually, I know we got about 15-20 minutes, so I want to allow some Q&A time. So I will go very quickly. My topic is more on the structural and functional aspects. Today, I'll be just very quickly touch on this, but I will make sure that we can probably do another session once it's get to the next stage of the rating system into detail. Now, the first step is, of course, to incorporate in general terms, and good study has been done already, and to detail. So today, I'll just try to touch on the aspects that we had to later on cover, bringing all that what Professor Ranjit said and Dr. Chandana gave a very comprehensive description of why, how we can combine sustainable and disasters and then getting that to a probably a rating system. So I apologize for if you see these slides, but I just make here some of these slides. But again, that to remind that why we are talking about all this is it is real and the disasters can happen. Now, this is the slide 1913 and 2012, the ice caps, and they are melting as well. So we see a clear difference, and climate change is real. You heard me saying this before, but now almost everyone in the world believes climate change, which is a big change last 10 years. So even these ones, the really ice caps melting, there'll be some other disasters. It can lead to the floods. It can lead to the sea level rising like that. So there are many effects which will affect the building industry as well, the green buildings and generally the buildings. So this one also is very clear. The temperatures are rising. I'll go very quickly. And this is a real one from 1880s to how the temperatures have like now risen in last so many years. I'll go directly to the 1940s. When you graph like that, you can clearly see it is happening. So we had to do something. And as Dr. Chandana has mentioned, we are actually target is 1.5 in 2050 to limit it, but it's going to be 2 degrees anyway. So this is the 2022. So it's really happening. And the book which you have heard me saying before, number of you, Mark Linus saying 6 degrees would be really the humanity will almost be in real danger of even vanishing when you get to very high levels. So we'll do something. Now disasters are going to come. So with this one, this is closer to Sri Lanka. We know the droughts have happened and in unusual ways. I was there a few weeks back and it was raining and the floods have occurred. So it's unusual. The climate changes. Everyone now believe that, and with the floods and droughts at different times, unusual times, the landslips. So disasters are everywhere. So what we'll do, I'll go very quickly. I'll not go through all the slides, but I want at least 10, 15 minutes for the Q&A. So I'll do it very quickly. So the sustainability and disaster resilience, as we have discussed today, it's really had to go hand in hand. You can't just really, that's why these green ratings, the DRR, to be included in that. So like Professor Ranjit and Dr. Chandana explained, why they had to be linked and to be really included. So the green is happening everywhere. Every building is being, architects being considered having the green aspects to buildings. And we in like 20 years back, if we saw a building like that somewhere in the world, people will think that something wrong with the architect, and that really getting this building, putting some plants and making it ugly. But that's totally different now, and everyone really likes it, and they want to see the green. So world has moved forward a lot, but same time, now we had to really even think about it. What happens if a disaster strikes, and we are not even considering in the design stage. I know that the additional aspects we are bringing to the buildings through the green side. So it's really a change we have to expect in the future. And some of the buildings are being built. What happens? We are putting these planter boxes. What happens to in an earthquake or some other disaster? We are just putting them in, but we don't really even incorporate them in our calculations. So this is something that I think world has to start looking at it. So this initiative by the Green Building Council of Sri Lanka, I think I really want to congratulate. Started this. This is 3 days back. 3 days back, I was in Indonesia, in very good place in Bali. I want to just mention what they're doing. This is a hotel which is going through green towards the zero waste. I just want to show it to here the initiatives in the world. This is one of the best initiatives I have seen around the world. The zero waste is a very popular place in Bali. So a lot of tourists go there. So they have got the bamboo construction to make it green and total zero waste. I will not explain today, maybe another day. I learned a lot from them, what they're doing. It's a lesson for all hotels around the world, what they have done. And here, the all plastics on the right-hand side, the recycled plastics. So every detail, they go into recycling the plastics from even a small thing they are recycling and try to make products and so on. Maybe I'll explain another day, and of course even so it's a learning for the whole world what they're doing in the hotels, what they're doing there. So just want to show you that where it's happening. Anyway, quickly onto the disasters. In my probably 5 minutes, maybe I'll take. But disasters are natural hazards. We know earthquakes, windstorms. Now getting into detail, what Professor Anji started and Dr. Chandana said, how incorporating them. Little detail, what are the natural hazards we have to consider in the future? Earthquakes, windstorms. Then we have the technical hazards. We can have like terrorism events or accidental events, accidental impact on the right-hand side, light aircrafts, and on the left-hand side, the blast, gas explosions, chemical explosions, the car bombs, the fires. Fires can be gas fires, the chemical fires. So all these hazards, disasters had to be included in our thinking. So if you started incorporating them, then you design a building, you are doing a risk study, you are doing a vulnerability, which is what is really the consequences, what happens if there's any disaster strikes. And then we have to start coming up with some protective solutions, and then the optimization. We have to do this optimization. Today, I don't have much time to talk about it, but optimization, you need to think about also reducing the materials. We are going for waste materials, all the sustainable materials in the construction, but we need to really think about optimizing the elements, and then bringing the sustainability aspects and try to do that and consider in this case, we talk about the vulnerability means we need to consider the disasters as well in terms of striking a building. So coming back to a little bit, very quick photo details, rather than going through details. Fire is the main one, which really we can design a green building. What happens if there's a fire strikes? Fire is there, then we could have really had to think about. This one here is what you see in the slide is where one of the worst fire disasters started. That is the cladding of the buildings around the world. There's aluminum composite panels. Going back to that, also aluminum composite panel is in between the two aluminum panels. There's a polyethylene, PE core. So why the world went for the PE core and this sort of aluminum composite panels is mainly for the energy conservation, because the sustainable buildings came. So then people like the architects and the others, the builders thought, let's look at some very nice one, which is really aluminum, looks very nice from outside, and then have a polyethylene core, which is to really for the energy side, to really energy conservation within the building. That led to this disaster. So this is a very good example why we go green, but we don't really consider the disasters. So the polythene in between the aluminum core just have a fire. You have seen some of my talks in this area. It's a big problem everywhere in the world. Started with one of the Lacrosse fires in Australia to Grenfell Tower fire, which changed the world with this the cladding fires. So ACP is a big disaster. Newer buildings will not have that problem, but many old buildings around the world have that problem. Australia, we have retrofitted some buildings, but still around the world there are many. Anyway, I'll leave that to another day. So this is how the sustainability could, if you're not careful, consequences under disasters, then actually that could lead to some other very serious consequences, what happened last so many years. Grenfell Tower now lost 180 odd lives. So this is why I think this the thinking of including the disasters is a very good thing. Then get into the earthquakes, the Christchurch earthquake, one of the worst around this region, 2011, the 180 dead, which changed the status in New Zealand as well as in Australia. We were looking at it. I will not go into detail, but these every detail once you so we can include sustainability aspects. So rather than demolishing buildings, the future is the really rather than trying to retrofit them. I remember Professor Ranjit and myself gave a talk in I think last year on this topic, and even recent one in Melbourne. But that we organized it's a big one. Rather than demolishing now, most of the buildings were demolished in this Christchurch earthquake. But if it happens now, we'll be trying to keep some of them like due to sustainability aspects. So we need to start bringing the sustainability aspects on the other way around as well. For sustainability, we need to consider disasters. Same way the disasters, when the disaster strikes, we need to think about the sustainability as well. So it could go sort of both ways as well. This is the big one recent one in 2023, the Syria earthquake. We can see also one of the main reasons for these damages is also the construction, the quality of construction. So that also has to be really improved for to bring that sustainability aspects. So some of the retrofitting it was done. I'll leave that to another day. And then when we are designing the structures let's say you get a simple house like this. When you're planning this house, we can make it sustainable, but same time think about the planning aspects where in this case the veranda and all that could be really isolated, put it separated. Otherwise, the whole house is going to get affected in a windstorm or a cyclone type of situation. So we can start thinking not just into that we are the sustainable to having the house or same sustainability, but do everything to make it sustainable, but same time do some planning to really avoid some disasters as well like this. You can not go hand in hand as three of us have explained today. And this is what I have done, but in one of the concepts, but it is not been built. There were some issues. It was not built, but foundations were done. But in Dubai, 1 kilometer tower. But in this case, the concepts of the wind flow through the slots, having the slots, we did the analysis in Melbourne, all this, introduced the slots to this building. But the planning stage, in this case, what I did was put some slots in that so that wind can go through. So in the planning stage, we can start doing that. So if the wind storms, the cyclones, we can also to optimize the structure. So that way make it sustainable. So these things will one day, I'm sure, will get appreciated. So the blast, we can talk about the blast. We have a blast happening somewhere. And then the windows being incorporated. This has what's called a PVB, some material core for the blast resistance. Same time, we can get the energy also conservation. So there should be some recognition for both, because then people can have a sustainable building as well as a resilient building. Like even this can be blast resilient because you are doing both, and that can go hand in hand. And I think that's so these are a bit more detailed, which I know I'm happy to answer if there are questions. But to really what you can do, start thinking, incorporating both sustainability and disaster, considering the disasters like this blast in this case. And then you do the structural optimization. It's another time, but we know the structural optimization is quite important these days. Rather than having we used to have just a very conservative structures, but now we could use this what is called topology optimization. You can maybe leave it for another day. The top one is really the sizing, the optimizer sizing. Second one is on the shape. Rather than having the left-hand side one, just go for the right-hand one. Third one is called topology optimization. We can save a lot of material here. So using sustainable materials is quite important, but same time, saving materials with optimized structure is also quite important. Now, this one we can put the any type of can be like not designed for any disasters. So this is a newer area which we will emerge in the next so many years. I think that's probably the last slide. I know last two slides. So this is one of the structures coming out of we have the BIM systems, Revits and all that can use this to optimize the structure and to reduce the materials. So rather than, and then you can get architecturally also nice shape. I know there are some architects in the audience that we can start working on this, the topology optimization using Revit type of tools to start with, and of other tools as well. But I think that's had to be done in the future rather than just designing the ordinary structures. We get aesthetically very nice structures as well. One last slide. It's really, we started talking about incorporating energy as well. So in this case, we can do all that, providing the sustainability, getting the renewable energy. We can get everything, you know, the wind farms to solars to geothermal to any other wind. But then we need to danger of not considering the disasters as well. In this case, you can see the solar farm, cyclone striking a solar farm. What happens? We are just relying on this totally on those solar power for the renewable energy. Then what happens? So this is an area we have to start thinking as well. In this case, we need to build some other redundancies. What do we do actually if the disaster strikes, and we'll be, you know, there won't be any power for so long if it's because to build these renewable systems are not easy. So we need to start. SDG goals, everything are fine, but we need to also start now practically what happens if a disaster strikes, and then linking that to sustainability. So that is what I think three of us were talking today. And yeah, so I think I'll finish there. I got a few more slides, but I think we ran out of time. So can I hand back to Dinishika? Thank you, Dinishika.
Okay, sir. Thank you very much. Can I share my screen, sir? Okay, thank you, sir. Okay, let's move into the Q&A sessions. If you have any questions, please ask now. Now is your time.
I think, Dinishika, there's a question on the chat side of Professor Ranjit Disanayake. Sorry, the Q&A side.
Hello.
Dinishika, there's a question in the Q&A side for Professor Ranjit Disanayake.
Hello, sir.
Yeah, can you hear?
Can you read the question?
Yeah, can you hear, Professor Ranjit?
Yeah, I can hear.
Yeah, so the question is from Mr. Janaharan, asking from you, when we think about sustainability, we need to consider the green energy and green government also, isn't it?
Yeah, of course, we have to think about definitely we are thinking about the green energy. Of course, the green, the governance, it is also must. Actually, it will be definitely included in the criteria. But this disaster risk reduction, of course, the partly we are considering, but as it is a present trend, we understand this is as the high. It is very much important to give emphasis on this one, and we have to measure it, the how much weightage we have given. If there are any part missing, we understand some areas is missing. through our research, we will wanted to the highlighted it, and then the rating tool will be more toward the rather than while thinking about sustainability, disaster risk reduction will be included. Okay, thank you.
Hello.
Krishna, there's another. Yeah, I think
Yes,
someone from the audience want to ask a question.
Can
yes,
I?
yes, Ms. Acharya, please
Yes.
continue.
Yes, I'm Aishwarya from Batiklo. Thank you so much for the super duper presentation and the explanation from big resources to two big resources. Thank you so much. It was a technical and very good knowledgeable presentation, and we gained a lot of things on green, the subject of green. That is very good. And my only one, it's not a concern, just to consider that when we are thinking about, when we are talking about the sustainability in the disaster risk reduction or disaster, so is it possible to add the content of enhancing knowledge to the people or to the vulnerable community, because the people, the community are now they are practicing to manage the situation. They know that the flood is there, oh the hazard is there, oh the risk is there, but they are they know that, and they try to manage the situation. They don't want to mitigate. Sometimes there might be the reason for that is the vulnerability. So just it was came to my mind, so just I'm sharing you to how to promote that too. Yeah, thank you so much for the opportunity.
Yeah, thank you for the question. Actually, Green Building Council of Sri Lanka, it's the most important thing is the awareness among the the general public, so that how we do it, because this is also awareness program, but this is more toward the professional. So we have, because it is a vast to educate the people, major big group. Therefore, what we are trying to do here, we have trained the professional, right? Then we have educated the professional, and we have the started the MSc program in sustainable built environment at University of Peradun, and we have included in the MSc program. Thereby, we have the big set of the professional who has been educated on the sustainability, so that it is their right also the educate the professional also. Therefore, I think it is a very, very important awareness. We do it, but we do it at a different level, right? So, including the today one, and we do a lot of awareness program in order to educate the general public as well as the including the politician, including the general public, everybody. We are trying our best to educate the people. Thank you.
Thank you sir, thank you so much.
Dinishika, may I also add something? Yeah, thank you,
Yes, sir.
Professor Ranjit, for that. I think that's he explained the role of Green Building Council to build the capacity and the knowledge of the community and the professionals and the practitioners. But as Aishwarya said, clearly said, the success of any development program, sustainability or disaster risk reduction program is solely dependent on the level of knowledge and the capacity of the community. So at the end of the day, they are the people who take it and run. Like, I mean, if you install the highly sophisticated early warning system in post tsunamis, but if the people don't know how to respond to that, then there is no point of implementing that. So then, yes, definitely, as you said, the developing disaster risk knowledge and sustainability knowledge is very, very important, and that is, without that, it's not going to be successful. Yeah, it's very valid point.
Okay, sir. Thank you very much. There are also questions in the chat box. can just reducing material quantity be a green solution?
Maybe I think we all can probably answer that. It's a very good question. Reducing the materials, it's a key now, because those days can you hear, Janushika?
Yes, sir.
Hello?
Yes,
yeah,
sir.
sure. So yeah, maybe three of us can go around and answer this. But the reducing the material means again that optimizing the structure. We didn't really even those days we didn't really spend a lot of time on that. But now that because we are talking about the full optimization, so try and really reduce the materials, not just going for as I mentioned, sustainable materials. Also, just giving an example, now the higher strength concretes, for example, have gone down the prices, the difference. So you can optimize like that, even going into a bit more detail on structural side, but the concrete strengths, and we are going for higher strength steels, we are going for green steels and all that. So they can be green materials, but same time reducing the materials. At the same time, I had to give a little bit of again, we shouldn't go overboard, because at the moment, because we had, when we were designing buildings, we added about 10% for the load, vertical load. Now that we can even go and add a couple of stories to buildings, we all get these inquiries, but to add a couple of stories to buildings. So we need to consider the future as well, future extensions to buildings and all that, although focus on that. So we have to try and balance all that when you, so rather than just going and taking the material everywhere, but at the same time reducing the materials. Now, I think Dr. Chandan has mentioned this, but even the earthquake forces depends, let's say for earthquake forces depend on the mass. So reducing the mass would not only reduce the foundation loads, the burden on the foundations, but reduce the earthquake loads as well. There are some other benefits, making it sustainable, also making it then attracting less earthquake forces, so the disasters side as well. So it can be carefully done. The answer is yes. Use the newer materials, composite materials will come, other materials will come, but try and use some waste materials. Now, the nature, Professor Ranjit also mentioned this, bringing the natural materials will be a big one as well. We are going to go get rid of some of the chemicals. For example, binders, rather than chemical binders, we are going for biopolymers. Now, again, that my experience last few days, looking at the carbon absorption, mangroves, seaweeds, all those things we were ignoring before. Now we are using them for the not only for the carbon absorption, we can use them as other ingredients for our construction materials. So some of these newer things are happening because of our now that this the large interest in the sustainability side. So that's yeah, I hope I answered that question.
Excuse me, Dinishika, may I ask a question?
Yes, sir,
Pushpa.
please. Please ask.
Yeah, thank you. Thank you for wonderful webinar, and thank you, Professor Priyan Mendis and Professor Ranjit Disanayak and Dr. Chandana. My question is, it's not a question, actually, does Green Building Council has the collaboration or the joint venture with the Disaster Management Center in Sri Lanka? Because, you know, recently in the flooding, the Batikalo Colombo Highway mostly flooded most of the days during the flood time. So can we suggest, or can Green Building Council, with the collaboration of Disaster Management Center, make possible actions to mitigate the issue, mainly the transport, A11 highway, the Batikalo Colombo Highway. So since I'm in Batikalo, I also stuck more than 1 week in Batikalo due to the issue. So shall Green Building Council make a suggestion or alternative solution to avoid this situation? Thank you, Professor Ranjit Disanayak.
Thank you, Engineer Pushparaj. Of course, we do have collaboration with the different organizations. I remember, like, we don't have the direct collaboration with the disaster the DMC. Of course, we can think about that direction. Of course, we can discuss with the disaster management center and see the possible the remedy on this. We will look into it. Thank you so much for the suggestion.
Thank you, sir. Thank you, Professor Priyan Mendis. Okay.
Engineer, Mr.
Pushparaj.
Engineer Pushparaj, I couldn't even come there. I was going to visit
Yeah,
you,
yeah,
but
that's why I took.
because of that, yes.
Those days, all
Thank you very
the
much for
road
that
is
comment.
flooded.
Exactly, but thank you for that comment. Very important.
Yeah, because we should take as an engineers and professionals, we should find a solution ourselves to suggest the government. Thank you.
Okay, sir. Thank you. Green Building Council of Sri Lanka offers comprehensive courses and training programs to train industrial professionals and undergraduates. This is our associate professional training program. So if you want to become a green accredited professional, this is the first step for that. Now you can register for our batch 46. Batch 46 starts on 27th of January. This is our next assessing and management of the organizational carbon footprint calculation workshop. We have to conduct this workshop on 1st and 2nd of March. You can register before 6th of February. Also you can apply for the green labeling for sustainable building materials and products to make them more green and marketable. If you want to know about our other training programs or workshops, you can contact us through our emails and our contact number. Thank you very much, sir, for conducting such highly inspiring and informative lecture, and you added value for our webinar. As an organization, we are proud to have resource person like you with us. And thank you again, sir, and all for being a great audience today. Stay tuned with our upcoming events. Thank you, sir. Thank you all.
Thank you.
Thank you.
Thank you, sir.
Thank you.
Thank you very much, sir.
Thank you, sir.
Thank you very much.
Thank you very much.
Thank you.
Thank you.